All right, so now we're going to talk a little bit about combinations where the order doesn't matter. So this would be things like we're picking a committee of people. So let's say that I have 3 people. I have Barry, Harry, and Larry. All right? And I want to choose 2 of them. It doesn't matter which order they're in, but I'm going to go ahead and show all the permutations. So I could either have Barry and Harry or Barry and Larry. Or I could have Harry and Barry and Harry and Larry. Or I could have Larry and Barry or Larry and Harry. So these are all of the permutations that I have. But notice, if the order doesn't matter, then these 2 are the same committee. These 2 are the same committee. And these 2 are the same committee. Because on this one, I've got Barry and Harry. It doesn't matter what order they come in. These 2, I have Barry and Larry. It doesn't matter what order they come in. And these 2, I have Harry and Larry. It doesn't matter what order they come in. So notice, I went from 6 permutations to only 3 combinations. So I divided the 6 by 2. And that's how you're going to do it. The formula for combinations of n choose r is going to be n factorial over n minus r factorial, which is the formula for permutations, but then we're also going to divide by n factorial. Okay, so for example, this was combinations of 3 people, and I was choosing 2 of them. So it was 3 factorial over 3 minus 2 factorial, which would be 1 factorial, which would give me the number of permutations, but then I'm also going to divide by the 2 factorial. And 2 factorial is 2 times 1 is 2. So that's why I divided by 2, and I got 3 as my answer. All right, so notice if I do 3 factorial divided by 1 factorial, that gives me 6, but then when I divide it by 2 factorial, I get 3. All right? Now, also on your calculator, you have combinations. So if you look on my calculator, right above the R, the 8, I have combinations of n choose r. So you can look for that on your calculator as well, and then you don't have to actually work any problems. Well, you still have to work the problems, you have to figure out the combinations, but you don't have to write it all out. All right, so if I said, what is, if I have 5 people, and I want to choose 3 to be on the committee. And again, it's a committee. It doesn't matter what order you take them in. And so this would just be combinations of 5 through choose 3. So when you're working these problems, what you want to ask yourself is, does order matter? If order matters, then you use permutations. If order doesn't matter, then you use combinations. Okay? So this is just a committee of 5 people. It doesn't matter what order you choose them in, they're all just going to be on the committee. Now, if you were doing choose 1 to be a president, 1 to be the vice president, 1 to be the secretary, then the order would matter. But just on a committee, the order doesn't matter. So this would be 5 factorial over 5 minus 3 factorial, 3 factorial. And so that would be 5 factorial over 3 factorial, 2 factorial. Notice that these two numbers are always going to add up to give you the top number. And so using my calculator, I'm just going to use this. I'm going to say 5 second function 8, 3 equals 10. So notice you won't have as many combinations of books or of people as you have permutations. Permutations is always way bigger because you're not dividing by this other number. All right? So let's go back to the books that we were talking about, the books on a shelf. So if I have 10 books, and I'm going to choose 3 of them, but it doesn't really matter what order I read them in. I'm still going to read these 3 books. So I'm going to choose 3 books. So since the order doesn't matter, I'm going to use combinations of 10, choose 3. All right? So that would be 10 combinations 3 would be 120. All right, so this would be, if I wrote it out, this would be 10 factorial over 7 factorial, 3 factorial. Remember, these two numbers have to add up to give you, or I should say 7 factorial over here, and then the 3 factorial. Okay? All right, so that's how many different ways, 120 different ways that you could choose any 3 books and read them in any order. It doesn't matter. Okay? Let's go back to the 12 students. Well, that's going to be 1. Let's say that we have 12 students, and we want 5 of them to be in the picture. So that would be combinations, and again, it doesn't matter what order the picture comes in. It's just going to be 5 students in a picture. So it would be 12, choose 5. So that would be 12 factorial over 5 factorial, 7 factorial. All right? Now if I do that on my calculator, I'll do it the long way this time. 12 factorial divided by 5 factorial, and then divided again by 7 factorial equals 11404,800. So notice I still have 11 million different ways to choose those 12. So notice that these numbers come out pretty high. Now, let's look real quick at Pascal's triangle. Because we can use this when we're doing combinations. Okay, remember, it's 1, 1, and then it's 1, you add these 2 numbers. So 1 always goes on the outside. So you add the 2 middle numbers to get this one. And then you put a 1 on the outside. So then I put a 1 on the outside, and I add these 2 to give me 3. So let's not put this one here. All right, and 1 plus 2 is 3, and then I put a 1 on the outside. Then this would be, put a 1 on the outside, 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4, and 1. And then let's do one more row. 1, and then 1 and 4 is 5. 4 and 6 is 10. 6 and 4 is 10. And 4 and 1 is 5. Then put a 1 on the outside. Now, let's look at the 4th row. Okay? Don't put a little 1 at the top. Just start with 1, 1. All right? So the 4th row tells us combinations of 4, choose some number. So if I look at this row, it's 1, 4, 6, 4, 1. So this is the combinations of 4, choose 1. Excuse me, choose 0. Then this would be the combinations of 4, choose 1. And this would be combinations of 4, choose 2, Combinations of 4, choose 3. And combinations of 4, choose 4. All right, so that's how that works. Okay, you can use Pascal's triangle to get these numbers. Now again, Pascal's triangle gets really big really fast if you keep on going down, and once you get to the 12th to the 12th row, the numbers are pretty big. Okay, all right, so let's say, and this is not, I'm sorry, this will be one more combination. Now I'm going to show you one that's not really combinations or permutations. Let's say that I have a coin and I toss it 5 times. All right, now remember that the number of ways of tossing it would be 2 times 2 times 2 times 2 times 2. But if I said, what exactly how many ways could I get 2 heads and therefore 3 tails? But I'm going to focus on the 2 heads for right now. So what this would be the combination of 5 coins, and I want to get 2 heads. Now the other ones would be 3 tails, right? So this would be 5 factorial over 2 factorial, 3 factorial. But notice if I said what's the number of ways of getting 3 tails, it would be the same thing. All right? Now I can use Pascal's triangle here because this is number of ways of having, this is a 5th row. So this is 5 choose 0, 5 choose 1, 5 choose 2. That's 10. And so the answer here would be 10. All right? So that's one way that you can use Pascal's triangle. And if you do it on your calculator, you will get 10. So I'm going to do 5 combinations and 2. And I get 10. All right? All right. Now, one thing that's not really permutations or combinations, let's say that I have a pizza parlor. And it has 10 different toppings. All right? How many ways can I choose those toppings? So let's say if I'm, and this has nothing to do with combinations or permutations. This is just talking about, this is probability, okay, or counting techniques. If I'm looking at pepperoni, okay, I can either have it or I cannot have it. So when I'm dealing with pepperoni, there are 2 ways for me to either have or not have pepperoni. And then I might have ham. So I can either have it or not have it. So with just those 2, there are 4 different ways that I can have it. 2 times 2. And then let's say that we have pineapple. Okay, have it or not have it. Times 2. And then you'll have all 10 of those toppings. And so that would be 2 raised to the 10th power. So 2 y to the x 10. So there are 1,024 different ways to have that pizza. So that finishes up combinations.